Hello everyone. Let us see the node analysis for AC circuit with respect to electrical circuit analysis subject. How the node analysis can be applied for a AC circuit. Node analysis for AC circuit. Let us take a problem to determine where we need to find V1 and V2 in the circuit. Let us take a circuit with respect to AC source. So this is my AC source over here, which is the to turn at angle 30 degree and have a capacitance. It will be minus J 20 ohms, and this is 6 ohms, and the inductor, that is J 5 ohms, a resistor along with the inductor in series to that, J 8 ohms, that is 3 ohms, a impedance we can say that 3 plus J 8, and one more resistor series to that is 4 ohms, and one more voltage source. The direction is given below, the current flowing is downward. So where the angle voltage given, find an angle minus 30 volts, find an angle 30 degree, and this is the ground. Let us apply the node for this. Let us take two nodes, one node over here, that is V1, another V2. There are two nodes. Let us write the equation for this node at node analysis. Node analysis at node 1. When I am writing a equation for node 1, that is V1 will be a reference. So always V1 will come first. So there are two voltage source. If you look at here, one over here, another is a V. There are two voltage nodes, right? We'll write the equation for that. It will be V1 minus 10 at angle 30 degree divided by 6. So we're writing a KCL. Obviously we're writing a KCL. I is equal to V by R plus V1 by minus J 20. So anyhow it will be minus 0 because there is no another voltage source in that branch. So it will be with respect to 0 here, minus 0, anyhow we can write only that term. Then plus V1 minus V2 divided by J 5 equal to 0. So if I simplify this equation, I will get V1, it will be 1 by 6 plus 1 by J10 plus 1 by J5, the coefficient of V1, and similarly V2, 1 by J5, and equating to 10 at angle 30 degree divided by 6. Let's take this as equation number 1. Similarly, at node 2, now I will take V2 as a reference. So V2 minus V1 divided by J5, V2 divided by 3 plus J8, V2 minus 5 at an angle 30 degree minus 30 degree divided by 4. That will be my second equation. I'll write that v2 minus v1 divided by j5 plus v2 by 3 plus j8 plus v2. So the direction is here is below, so hence v2 minus of minus will become plus. If it is above, it could be positive. Here it is not given, hence I have taken as a positive here. That will be v1 minus. So here if I take minus of minus, it will become plus. It will be v2 plus 5 at an angle minus 30 degree divided by 4 equal to 0. If you simplify this equation, you will get minus v1 by j5 plus 1 by 4 plus 1 by 3 plus j8 plus 1 by j5 into v2, that is equal to minus 5 at an angle 30 divided by 4, equation number 2. So whenever we have a AC source, when I am applying a node analysis or mesh analysis, we have a AC circuit, so that will be having a complex term. So here determining the unknowns using your calculus will be difficult. For that we make use of a Cramer's rule. So that is where we find a delta first determinant. So from the equation 1 and 2 we get equation with respect to v1 and v2 coefficient equal to this equation. Let's write that. So if you look at the first equation, I have v1, that is 1 by 6 plus 1 by j5 plus 1 by j10, 1 by 6 plus 1 by j5 plus 1 by, you can add that and you can write a single value. Okay, since I am writing here directly, and v2 is minus 1 by j5, minus 1 by j5, and the RHS side is 10 at angle 30 divided by 10 at angle 30 divided by 6. Similarly, from the second equation, I have v1 term as a minus 1 by j5, and v2 coefficients are 1 plus 4 plus 1 by 3 plus j8 plus 1 by j5, and this is equal to minus 5 at an angle 30 by 4. So I need to find a determinant of this matrix, that is a delta, we can say. So this you can erase here. This is a Cramer's equation. For this is my delta. I am taking a determinant of that matrix. I am taking a determinant of the same thing which you have. Just take the same thing and to find a determinant of that. Once you get the determinant value, whether it in a polar form or in a rectangular form, polar rectangular form, you will get a delta. So next I need to find a delta 1 to determine v1, and I need to find delta 2. How do you write delta 1? That I will replace here. Replacing the first column, so just I will go here, replacing this first column with this value, this column. In the first column with this column will give my delta 1. I can write as, it will be equal to 10 at an angle 30 divided by 6, and another value minus 5 at an angle minus 30 divided by 4, and the second term I will retain, that is minus j5, 1 divided by minus j5, and the second term 1 plus 4, 1 plus 4 plus 1 divided by 3 plus j8 plus 1 divided by J5. So this is my delta 1. If you find the determinant once again, so this into this into this, minus this into this. If you do this, you will get once again a delta 1 either in a polar or in a rectangular form. So once you know delta 1, delta 2, I can determine V1. V1 is equal to delta 1 by delta. So this is where we get the answer for V1. Whenever we have a complex along with a AC, you can't solve this in a calculator, so make use of a Cramer's rule. Similarly, we can determine for delta 2 also. Delta 2, now I will replace the second column. Instead of first column, I will replace the second column with this column. Okay, second column with that column. So once again, if you find that, you will get a whether in a polar or in rectangular, you can keep in any one of the form. Then you can find V2, that is equal to delta 2 by delta. We will get the answer for V2 in terms of volts. So this is how we need to solve the problem whenever we have a AC circuit for the nodal analysis, to determine that also using a Cramer's rule. Okay, thank you.